All right, we're still working on automating exploratory data analysis and focusing on bivariate relationships. In the last video, we improved upon our analyses of numeric to numeric relationships by including besides the Pearson correlation, a Kendall's and Spearman correlation, along with some univariate features, which we had already used, calculated in a prior video on univariate statistics, but some stuff that might help us make a decision as to which correlation might be most appropriate for us. I want to make one more change now to the bivariate analyses before I move on and start automating some of the data cleaning issues we've identified previously. In particular, when we have C to N and to C to relationships, when there are multiple categories or multiple groups in a bar chart. So for example, in our insurance data set, we've got region here, and we calculated an ANOVA F and found that, yep, region does have a significant effect on how much people cost in insurance charges. Well, that F score is great at telling us that there's an overall difference among these categories, but it doesn't tell us if individual differences between pairs of regions are significantly different, which can sometimes be useful for decision making. So for example, Northwest and Northeast have a much smaller difference than Northwest and Southeast. Are they all statistically significantly different, or just some of them? That's something I like to add when I'm printing out statistics next to my bar charts. And I can go through and calculate a t-test instead of an ANOVA to show me all those pairwise differences. And then I like to show only the significant differences here in the notes next to my chart. I still like to keep my overall bivariate relationship table clean and not include all of this stuff. So I'm only going to include this when I make my bar chart visualization. So to do that, let's go find our bar chart function that we made. Here it is. And I'm going to start. This is going to be a little complicated. This was our tougher one. You might remember we had to go through and create these group lists to come up with those one-way ANOVAs. Well, that was somewhat hard. The t-test will be a little more complicated. So if you can't get this or don't follow along fully, that's okay. At least if you can copy my code and get it to work, you'll be well on your way, even if you don't fully understand the logic. But I'll do my best to explain. So here's where I want to start. Let's begin after our ANOVA F that we just calculated. So let's make some space for this. Calculate individual or pairwise, whatever you want to call it, t-tests for each pair of groups. I'm going to start by just making a simple list. And honestly, you might think of a better way of doing this than me. I'm not the most eloquent programmer in the world. If you are, you might come up with a better one, and please feel free to share it in the comments and I'll make a better video. But for now, this is how I'm doing it. So I'm going to make a list of t-tests, and then I want to identify only those that were significant, and I want to not repeat t-tests. So for example, I can go through and make a loop that will calculate a t-test between Southwest and Southeast, Southwest and Northwest, Southwest and Northeast. But when I go to my next item in the list, I no longer need to calculate a t-test of Southeast with Southwest because that was done in my previous loop. I only needed to calculate a t-test between Southeast and Northwest and Southeast and Northeast. Same thing when I get to Northwest, the only one left that's unique is the relationship between Northwest and Northeast. I don't need to go back and do a t-test with each of the others. So I'm going to make a nested loop, and I'm going to keep track of which test I'm on and make sure that I only calculate the total number of unique tests, because if there's a ton of groups, this can start to take a while, and we don't want that to happen. So I'm going to start with a for loop here, and I'm going to make an iterator to keep track of which loop I'm on. So I'll call it I1 and G1 for group 1 in, and I'm going to enumerate through the groups object that I created above, which was the list of unique groups right there. Once I'm going through each group one at a time, let me just show you what's going on here so you get the idea. The best thing you can ever do to understand code is make sure you print it out repeatedly every time you make a minor change. Oops, not Q1, G1. So let's run this, and I'm going to cancel out Smoker and do this just for region for now. All right, so here's what's getting printed out. 0, Southwest, just a list of each of those group values, along with which iteration I'm on. Hopefully so far you're with me. What I want to do now is loop through for each one of these. I want to go loop through all the others and then calculate a t-test with them. So I'm going to put in here another 4. I'm going to call this an I2 G2 in re-enumerate through groups again. And this time, I'm only going to print. Actually, let me, first of all, before I do that, let me show you what happens if I don't add this if statement I was about to run. If I just print this again, here's what I'm getting. So it goes to southwest, and then once I'm on southwest, it's going to re-enumerate through all of the groups once again, and then print out, let's see, iterate through the first, iterate through the second, print this one out. So it prints out the everything in groups. I'm surprised I thought it would be 0, 1, 2, 3. Oh, yeah, I know why. I'll show you in a second. So what I want to do is, let's now print out both I2 and G2. This is what I forgot to do. So you can see both the outer loop and the inner loop. So when I go through the outer loop, this 4 right here, it starts with southwest. Then I go re-loop through everything, and the first one in the list is also southwest. I don't want to create a t-test of a group insurance charges with itself, so I want to skip that one. But then this inner loop will continue to run through all the other groups. So southwest against southeast, northwest, northeast. I do want that. When I get to here, I don't want to calculate this one because it was already done right here. So on this first time through the outer loop, I want to skip this one. The second time through the outer loop, I want to skip both this one and that one and only calculate these two because those are the ones that are new or unique that weren't compared in this prior list of 4. When I get to my third iteration, I want to skip all 3 of these because all 3 of those already appear in the reverse somewhere above. And I only want to calculate this one. And then lastly, I don't need to calculate any of those. So what if we did this? What if I just put an if statement here and just said if I2 is greater than, not or equal, just greater than I1, then print. Now look what happens. So I2 will only, so this logic will occur only if the iteration I'm on the inner loop is greater than the iteration of the outer loop. And what that does now is it repeats each pair only once. Southwest to southeast, southwest to northwest, southwest to northeast. Then I get southeast to northwest, southwest to northeast, and then finally northwest to northeast. So that accomplishes exactly what I wanted. In other words, here in this spot is where I'm going to put my logic to calculate the t-test now. So let's go ahead and append to that list we made above, t-test.append, and I'm going to need to, I'm going to make this into a string here. So what I want to do is have a list with the name, I just want the name of the relationship here, name of relationship here, and then I want the t-test value here and the p-value right here. And then I'm going to print these out in a loop down here in my chart. So you'll see what I'm talking about in a second. The name of the relationship, what I'm going to do is just build an F string. And I'm going to say group 1 or G1 compared to G2. That's the relationship. Yeah, that's good enough. And then right here, the t-test, I've got to calculate it first. So I'm going to calculate that right, I guess, above right here. So the t-test will be, let's put this T and P right there. I'm going to set that equal to stats.t-test. It's called IND. And I need to pass into this the list of charges for each one of those groups. So I've got to filter down the data frame and just go by the charges label where the feature equals the G1 and the G2. So to do that, hopefully you remember these things, it's df, and here I want the feature to be equal to group 1, and then I only want, actually I won't do it there, I'll do it right here. The only column I want here is going to be the label column. So this filters the entire data frame down to just those that equal group 1, southwest. And then it only returns a list of the label, which is charges when this gets passed in. So hopefully you see how this right here is giving me a list of charges. In fact, you know what? It might be easier for us to print this out. Feature, you know what, I'll call it just list 1. And then list 2 is going to equal the same thing, except where feature equals G2, the one on the inner loop. So list 1 is going to be a list of charges where region equals southwest, and list 2 will be a list of charges where region equals southeast, G1 and G2. So then I've just got to pass those lists in right here, list 1, list 2. That'll return a t and a p value. Let's go ahead and round those using our round 2. P round 2. All right. I think we're good. If you need to, you can print out these lists to see exactly what's happening there. But that should give us now a list of t-tests. I'm just going to go ahead and print. Yeah, let's go ahead and print out that whole list out so you can see what we're getting from this. All right, so here's our list and sub-items. Southwest to southeast, t-test, p-value. Southwest to northwest, t-test, p-value. All I need to do now is when I build out my text string, I just want to print all of these out. But you know what, to keep it simple, that could be a lot of relationships if there's a lot of group values. How about we only print out the ones that are statistically significant? So I want to loop through these or somehow eliminate those, or I could just not append them in here in the first place if they're not statistically significant. Actually, no, I can't do that, and here's why. Good practice in statistics is that when we're making a lot of comparisons among group values, we should correct for that because, I mean, we've got, what, 6 total here? Something like that, 6 comparisons. Sometimes you might get 100 comparisons. Just by pure chance, by random probability, if you have 100 comparisons, 5% of them are going to have p-values below 0.05. So you might find what you think are statistically significant relationships or differences simply because you calculated so many t-tests. So to combat that, we make what's called a correction. And there's lots of different types. I think the simplest one I'm going to do here is called a Bivariate correction. And all that means is we have to adjust the p-value. So let me show you how we'll do that. Make a Bivariate correction, which means adjust the p-value threshold to be 0.05 divided by n of t-tests. So we basically just say a smaller p-value is needed in order for us to call this significant. So what I want to do is as we go through to add these to the chart, let's only add it if it's below, first of all, we better calculate Bivariate. Bivariate equals, I'm going to hard code it in. Well, is that a good idea? We could always add it as a new optional parameter up here. So we're going to call it p threshold, or just p. And I'm going to set that equal to 0.05 by default. So anyone who calls this can override it if they want to. And we're just going to say that Bivariate is going to equal that p divided by the number of t-tests that we calculated above here. How do we get that? Well, we've got this list, and each item in the list represents an individual t-test. So let's just say divide it by the length of t-tests. Count up that list. So our new p-value threshold is not 0.05. It's what Bivariate is right there. Maybe that would be worth adding to our output just so that we're aware of it. So I'm going to add text string plus equals Bivariate, so people understand how we're adjusting this. Bivariate p is going to be Bivariate. There we go. Now let's have a loop here for t-test in t-tests. Let's loop through those, and if t-test, the p-value, which would be, it's the third item in the list. So if t-test 2, because it's a zero-based index, 0, 1, 2, if t-test 2 is less than or equal to Bivariate, Then let's go ahead and add a text string, or add that one to the text string. So text string plus equals, and how should we do it? Should we print a line break between each of them? And we could move this up to the top and then just print them down the list. Or we could print them out to the side. I think I like doing that better. Let's move the placement up to the top, like 0.95. And then each time we find one that's significant in the list, we will first add a line break, because I'm not adding it here, just in case it's not needed. I don't want to add one in case nothing's significant. So I'll put the line break first instead of putting it at the end like I did up there. And then I'll say I want the relationship name, which is going to be t-test, the first item in the list, which is index 0. Remember, that's what we put right here. It's that southwest dash southeast. That's what I'm talking about, putting that right here. And then let's give it a colon, and then let's add the t, which is t-test1. Do we just always know that's the t? We could put t right there. I don't know. You can decide how you want to do this. And then P, you can format it whatever looks best to you. That's the one in the second position. All right, let's see how that looks. Oh, I need to turn off that printing. Oh, and look where it started it, way up here. I don't want it to be that high. Let's change this to, first of all, let me get rid of this print. And then let's make this something like, I see, does it format that at the bottom? Maybe I did want what I had before, 0.05. That's right, because that's how it lays it out, starting at the bottom. Yeah, maybe I'll even go up to 0.1. Something like that. Okay. So now we get, oh, I forgot to use round 2 on my Bivariate P. Let's do that right here before I forget. Here's where I do that. Round 2. Okay, that's better. So now, according to this, oh, something didn't work quite right, because all of my p-values came out as significant. So somewhere I've got a logic error, which is not uncommon. I do that all the time. I put here if the t-test, if the p-value is greater than the Bivariate value. I don't need greater. Hopefully you caught that before. I want less than. I only want to show it if the p-value that I get back is less than the p-value threshold, which in this case was only, that doesn't sound right to me. P of 0.05, did I do something else wrong? P of 0.05, P divided by length of t-tests, which should have been, I'm going to print this out, print P and then length of t-tests. Length of t-tests should be 6. So let's see what I got here. It is. So the P, oh, it got overwritten. Remember, because we passed it in right here, P, and then it got overwritten when actually got overwritten right here. Again, we just need to use a different name. So we're going to call this P threshold. P, I like that, P underscore threshold. I don't use that anywhere else, do I? Hopefully not. And I'm going to use that one down here instead. I think our logic is sound now. Let's take a look. That's more like it. So based on a Bivariate adjustment, none of them were significant. None of them individually were, even though our overall, oh, and then according to this, our overall F score is not significant either. That should be. That p-value right there. Let me see what I'm doing wrong. The p-value, oh, it got overwritten. That's our problem. So when we calculated the ANOVA here, it got overwritten by the t-value there. So let's change that to a TP for the TP value, and then TP right there, so that this will remain P, which is what we wanted to print down here in this image. So I'm going to leave all of this in just because I want you guys to see how I solve and work out my own errors, for those of you that are new to programming. That's more like it. Okay, so that's a p-value for an F like that. The Bivariate adjusted p-value, because we had 6 total pairwise tests is going to be much lower than 0.05. And our logic says only show the t-test results if they're below this. You might change, you might prefer, you may decide, you know what, I don't care. I want to show them anyway, and then I'll just include the Bivariate. And when I look at this, I can just know for myself that, okay, the p-value, it's significant, but it's not significant when I'm using the Bivariate threshold. And so it's up to you. If you could still leave these in there if you prefer, whatever you like. In fact, you could turn it into a parameter like this. Sig t test only. We could default that to true. And then we can say down here, if sig t test only is set to true, then we'll use this if statement and only show it if it's true. Otherwise, show it no matter what. So if they've got that set to true, then it will use this criterion before it decides whether or not to display it. Otherwise, if that's set to false, it will always display it no matter what. Anyway, like I said, you can customize these functions to your heart's content and make it work however you want, but don't leave that print in there. There we go. Last thing. Now we've got a cool bar chart function that not only shows us whether or not the overall difference among bars is significant, but also gives us the individual pairwise t-test. Let's try it on something with a lot more values. So, for example, I like the airline data. Let's do one of these. And rather than do gender right here, let's use one of these Likert scales. Departure, convenient time. I think in-flight entertainment was a good one to do. That was something that mattered to people a lot when determining their satisfaction. So I'm going to grab that one. And let's run it down here. Bar chart, pass in df airline, pass in the feature, I just pasted it, passed in the label, satisfaction. Okay. Oh, is that not how it's spelled? Oh, it is satisfaction. Oh, this is good. Let's take a look at what we got here. In-flight entertainment. It looks like it is not properly determining when we call it. There we go. I switched the feature in the label. That's my problem. When I call the bar chart, the categorical one has to be first, and the numeric one has to be second. We could add logic, actually, make this more robust, so that it automatically checks for us in the function. But I'll just go ahead and do it the right way for now. Okay, so now we've got, satisfied customers were much more impressed with the in-flight entertainment than dissatisfied customers. There were only 2 values here, so there's only one P. As a result, the Bivariate didn't change because it was dividing that by 1. I should have thought about that since there's only 2 values. But yeah, very, very strong T right here. I think it would be cool to make that function a bit more robust. So here's how I would do that in case you're curious, or if you're bored and want to stop, you can end the video now. But I'm going to solve that problem in my bar chart function. So when it first comes in, I think I'm going to use the same logic that I had up in our stats function, which is down here, this one. We check the feature to see if it's numeric. If it is, then we mark a num and a cat rather than a feature and a label. You might recognize this from our prior video. So just in case I ever decide to call the bar chart function outside of the bivariate stats, I want it to work no matter what, because I don't want the logic to be just there. make sure that the feature is categorical and label is numeric. So to do that, we're basically just testing. I don't need the skewness anymore. We're basically just saying, is the feature numeric? If it is, then set the feature equal to this new label called num, and then make the label cat. Otherwise, make the label num and make the feature cat. And then what this means is we're going to use this variable num everywhere below where we were referencing the label. So in mine, that would be right there, label, num, num, num. I think that's it. And then cat will be right here where the feature is. Cat, 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 cat. There we go. So now it won't matter if I do this wrong again. So we've made it more robust. So right here, I'm going to go back to putting satisfaction second. And it will automatically flip it for me. And still put satisfaction at the bottom like it did when I had it previously switched. So that's the idea behind automation. We want to make it work no matter how many group values there are, no matter what the calculations are, and allow things like allow them to input in any way they want. Yeah, we just make it work even in spite of any possible errors. Hopefully this was helpful. We'll stop here and proceed in the next videos with some more data cleaning.